So basically, my name is Sam Chang, and uh, okay, this course here is artificial neural networks, but actually the original title is deep learning, but maybe it's actually not bad to have the title artificial neural networks. Um, and so, and like my other course in the same semester, like I have a computer vision course, and actually my other course like last semester, I started to use Discord instead. Previous I use PR, so I find Discord is more convenient and it's and basically it's if you don't know what is that, it's a kind of discussion forum. It's a private discussion forum. You can just create a server, invite people to join and so on. Um, and you should find the link there. I see some of you guys already joined it. I put the link on Canvas. Um, so of course there's no office hour, but you can contact me through Discord. Um, if you have public questions, I mean, in the sense that some materials are not clear, and maybe you have some topics are interesting you want to share with others, um, it's good to pose as a public question. Hopefully, it will initiate some discussion, and everyone probably is yeah will be interested to look at those. Or you can send me private question, like if you have something really I don't know concern with something oh uh, quite personal, and basically the logistic is I we have using multiple technologies. Of course, we have Canvas, um, and then I have Discord like to discuss whatever stuff, and I will put like most materials on my own website. You should be able to find the link. I didn't put it here, but it's also on Canvas as well. Uh, and of course, we're using Zoom here, and the video, unless we came into like particular technical difficulty on particular lecture, like otherwise it should be recorded, and I will put the link on the course website as well. Um, that's my personal research interest, like some computer vision, machine learning, and so on. Um, oh, actually, like as I mentioned, I didn't yet, but uh, I it's not a big class. I really want to get some input, like just say from you guys, like what was your background and so on. So please sign up to Discord, like maybe just say a few words about like what you're working on, like the project that you're working on, and maybe a little bit background. I don't know. Um, and and as far as I don't know, like how much you have already exposed on deep learning or like neural networks. Uh, of course, nowadays a very powerful tool. I guess I would say like the most important and powerful tool like for research nowadays. Even though like having said that, like also like if you just uh arbitrary create a MLP like multi-layer perceptron like for a particular any problem, or like even maybe borrow some architecture like Google Lab, Westlat, and say a particular application. Um, you probably cannot publish that in top journal. Maybe you can get away with like small conference. Not very competitive conference. Um, but on the other hand, it's like a very important technique because it just works. It works really well. Um, and if you're aiming for industry, then in particular, or like if you want to start your own startup, then like it's a very useful technique to know. And and because of that, there's actually lots of like courses like online. Uh, I just put a few here, like of course, like Jeffrey Hinton, like one of the like I shouldn't say founders. Yeah, I guess like many people like considering fathers of neural network. Of course, like or like at least fathers of deep learning. Um, and he has a course like it's like date back like I'm not sure you can still find. I probably not. It's like it has a Coursera course like back in 2012, I guess. And of course, like, there's a famous Stanford 231N course, and there's a course on Oxford. Like I'm not sure it's still there. I think there is a you can find it on YouTube. Toronto has a course as well. The Australia, I'm not sure he still have the course there. Like because he used to be, I don't know where he was. I forgot. In a university in Canada, but I think he moved to Google Brain as well. I'm not sure his course is still maintained. I mean, of course, he had put a course on YouTube like in the past, but I'm not sure it's still there. Uh, Yang LeCun is another consider the big three, I guess, of deep learning. Uh, um, Also along with like Hinton and also like Yosha Bengio, like in University of Montreal, and he has put up a course pretty recently as well on NYU. Of course, he's also like the head of like Facebook research. So he has two posts. And basically, by the way, like, all these guys get pretty famous and rich uh, on this area. Like Hinton, I don't know personally like how wealthy he is. I didn't know, and honestly, but if just think of LeCun, for example, like he's head of like Facebook AI. You can I don't know what I I expect that he should get some stock kind of incentive from Facebook. I don't know. And also like Yosha Benjo has its own company, but um I don't think it went too well. But personally, he's still like doing quite well. I guess it got 10 millions out of that. I don't know. Um, but yeah. Anyway, and I'm saying there's another course I call Fast AI. I guess it's like from Cal State. Um, there's more hands-on, I believe, and the group also like developed this like Fast AI library that is basically on top of PyTorch. So you may want to take a look like at the library because like, if you use PyTorch, you may find FastAI is quite attractive. It's kind of like if you know Keras and like TensorFlow, it's kind of like Keras like yeah, it's like Keras on top of TensorFlow. It's like this FastAI is like something like similar like on top of like PyTorch, kind of simplify. Even though I would say PyTorch is like quite neat already like but it's just like shorten some of this even further. In particular, for example, it load the um some it loads some of this online data set like quite easily, so you can easily just use the fast AI kind of package to load those data set like quickly. For example, um, MNIST, something like that. Like you can load them right away. So by the way, what's this course about? Like is I say some history, but honestly, it won't be lots of history because I'm not a great historians or something like that. We'll look into tech least and applications and yeah, so what we so-called deep learning, of course, is mostly in hyper world of like artificial neural networks. Um, and this area is moving very quickly. Like I think like we first introduced this course, I forgot like 4 or 5 years ago. I forgot now, like maybe 4 years ago. And at that time, like I think TensorFlow didn't there like it's like it's version like 1 or below version 1.0. I forgot. Like maybe it just came out, and now of course like TensorFlow is kind of dominating the all these open source packages, and uh, and especially for the first couple of years, students got like uh, at that time, of course, and now maybe it's getting harder. Like if you want to get a really quick paper out of this, maybe not as easy as the first year when it's really not a lot of weak people. Like of course it's still many already like at that time, but now it's like really quite bit crowded. But even that, like this techniques I would say is so useful. You have to know that like even though like you may not end up using this to write the paper, but assuming you just graduate for a master or like even you get a PhD, you this is like some kind of knowledge right? You're supposed to know, I would say. Uh, and especially for master, if you go out like to go for industry and uh, I don't know, like anything working on related to AI, I assume that like they expect you to know some new laterals and maybe know some of these packages as well, like able to create some simple new lateral solutions for that problem. So and hopefully this will be helpful for your research. Uh, so the expected outcome of this course, I basically uh, twofold. It's not twofold. So I hope you guys I will be able to use some of these open source packages. You don't need to know all of them. Apparently, you just need to get familiar with one of them. Maybe PyTorch, maybe TensorFlow, or maybe even MXNet. Um, Personally, my students I might use PyTorch. Actually, mostly my students I play with PyTorch like just through the tutorials, but I don't really wrote many models myself. Um, I personally prefer PyTorch. I don't know about TensorFlow. Uh, Version 1.0, I would say this computational graph is the problem is not hard. It's quite hard to debug. But I heard that like it's merging more and more like PyTorch. I don't know. Like maybe you guys can explore and then like can share more what you know. Um, by the way, that's one thing. Like all of you guys are going to give a presentation. This is part of the your how we grade this course. It's like 20% will be the presentation. That include like writing a presentation abstract and then like also grading each other. Basically, you will have a chance to do a peer review and then the presentation itself like maybe 10% of the cost. And when we first offer this course, like all the presentations are more or less focused on the packages because at that time packages are quite new and there are many packages basically like for example there's Lasan like now there's also Fiano um, and those are nowadays are getting more obsolete. So, but since like last year, I guess like that more presentations are on different topics that recent researchers are on papers or like anything else. So, but of course, I related to artificial neural networks. So, but for example, if you want to explore like more about TensorFlow, in particular, the current version of TensorFlow, how it changes like from previous version, like you can definitely talk about that and share what you know. And so again, I sorry I digress. So the expected outcome is I used to be able to use some of these open source packages to construct neural networks to solve your own research problem. That's one of the goal. The other goal is like hopefully we will build a sufficiently strong like theoretical foundation for you guys that you will be able to understand current NN research. So if you, I won't say like you can easily flip through a paper and understand everything. I would just say like by the end of this course, hopefully like you have enough background, it will make you much easier to try to understand those papers. So and and the logistic or like I would say how the course is like I mean how you will be graded will be like 20% will be homework assignment and that's will be mostly based on Python. um, actually, I would say completely based on Python. So I can't expect you guys to be able to write in Python. So if you don't know Python already, like you probably want to spend some time learning that. I won't really spend much time like yeah, I don't think I will spend time like teaching Python here because it's a graduate course. I assume that you guys can learn it yourself. And it's I mean learning to program is easy. I shouldn't say easy, but in the sense it would be boring if I talk about okay, this is a for loop, this is like something like in class. So because you can figure it out like just and there's like so many tutorial out there that you can okay, I mean learn it very quickly. And to be honest, I'm still a MATLAB person like deep down, but I write quite a lot more Python nowadays. And but I often still quite completely remember the syntax and I always need to like Google like here and there. For example, like uh, I'm not sure you're aware like the course website like I that just basically copy from the other from the last offering from last year, but I need to change the date there. So like just yesterday I wrote a simple script just to change the day uh, from I mean just change the data in the on the website. So of course I don't remember all these commands there. For example, like there's a object called datetime that I can get the return the current day was today and stuff like that. And but yeah, you can easily Google that, so you can easily figure that out. Um, okay, that's about the homework. And I already mentioned that's presentation. That 20%, it seems a lot, but like remember that include the presentation abstract and also like there's a around 5% for peer review, maybe less than that. I don't know. If you have 7%, I'm thinking like I will give half a point like for each uh, um, review, so it would be like 3.5 points, and the left would be like would be yeah something like 5 points would be maybe the abstract, and then like yeah I don't know this presentation itself would be a little bit more than 10%. So we have the final project, we're trying to 40%. This time I will try to push you guys a little bit earlier. I used to be like just ask you guys to write ask students to write um a project proposal and then a final project. But this time, I guess I want you to write the prepare the proposal earlier, and then I maybe also write them kind of progress report like in um, the progress report. I guess I forgot how I put it. Like maybe like it's 10%. I forgot. Yeah, and then the file report maybe 25%. So they sum up 40%. So that would be a midterm also, but we so-called midterm. But honestly, it'll be I guess most likely it will be arranged like in mid April or late April. So and it will be more. It, of course, it will be like a take home, but you shouldn't consider it as take home because I will expect you to finish in 3 hours, something like that. So and and of course because it's uh open book like because it's like a take home like it's open book open note and open to the internet as well. So I will try to ask question that it's not so easily you can Google that. I will see how it works out, but yeah, expect that it's going to happen around like mid-April or something. And there's also like extra credit that would be like in class participation. So it's something like um, I want to just get some. Otherwise, you guys will just fall asleep. Like with some incentive, you stay in class. So I every once in a while I just ask some quiz, but sometimes it's not exactly quiz, but maybe just um, simple questions. So to see if you are still around. So if you answer correctly, you get 1 point. If not, you get like half a point. So anyway, you get some point basically. So just hopefully you um, stay in class. Um, there's no this is just a reference textbook. That's not mandatory. Also, like I picked this one because this one is also online, and of course I all Goodfellow and also Banjo, like they are all kind of like very famous researcher in this area. It's a pretty good textbook. But I'm not going to follow it really. But you can take it as a good reference, and maybe you can browse through that to see if you have any idea, for example, for presentation and for project. By the way, a remark for project and presentation, the difference between these two is for presentation, I don't expect you guys to actually get your hands dirty. You can just read the paper, try as much as you can understand the paper, and then present it. So you 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 can just present according to what you understand and what the readers have written. So, but for the final project, like if you can still work on the same paper, but I will assume that I expect you guys to get your hands dirty. Basically, if you read the paper, you should have tried to implement that as well. If you decide to use that paper as your basis for your project, and hopefully, if you can kind of like improve upon the paper, that would be great. If not, you at least you try to, I mean, we implement that, and hopefully get to understand more about like what the paper is talking about. Uh, so it, actually, it's quite different to define the scope of the final project because it really depends on like what you pick. For example, like if you pick a paper, the source code is already available. You just test the source code. Of course, it won't be sufficient for a final project or like a satisfied final project. So, but on the other hand, you still like can based on what the open source like available. But in that sense, that you should be spend more time trying to understand the code and see how you're able to improve that. So on the other hand, if like you have the paper, etc., the source code is not available, and you're trying to implement that from scratch, then of course the expectation will be lower, like whether you can improve that. But that one like will be like the emphasis will be like whether you can replicate the work. So oh by the way, the website is here. Uh okay, now I guess I will test on this what I want to say, this quiz thing. So you can try to uh I guess the easiest thing is you just like type on your chat Zoom chat box, or just send it to everyone. That's fine. If you want to send only to me, make sure you send to the host. Don't send to, because I have another login as well. Usually, send to the host, but you can just send to everyone. So let's say like I just want to do this kind of like quick survey here. So, um, what is your favorite package? Or did you try any of these packages before? If you don't, you can just say none. Um, or like if you have tried multiple of them, like which one is your favorite, or like the one that you use uh, most often? Uh, are you guys still here?
Yeah.
Yeah. Okay. You want to? Yeah. You want to send me? Yeah. So I have an idea like what is the background you're coming from. So that's it. Any. Uh, so I have some response. Okay, that's good. Let's move on. Uh, okay, I have a idea. So how about programming languages? Like maybe several of you say that you didn't have like any play with any of these packages before. Uh, what out of all these languages, like which one you're most comfortable with? okay, that's good. Like, yeah, several of you like use. Oh yeah, you use one of using R. Then must be like from science, like and uh uh maybe I don't know, statistics department. Uh yeah, you want to. I have very little exposure. I pay with the R tutorial before, but like I forget more or less forget everything because I don't actually use it like daily. Uh, but yeah, I would say it's similar. You probably want to learn some Python like for this course because basically I shouldn't say you should it's better. Like I think like you should really learn Python like for this course because if we talk about all these packages like maybe as that except this Macconf lab, this is a have a it's based on MATLAB, but the problem is that Macconf lab is only for convlat. It is convolutional neural networks, and for example, you cannot build like recurrent neural networks with that. At least I don't know whether they have update like um, at least 2 years ago. I didn't look at that like recently. Like you can only build like convolutional neural networks with that one. Um, and all of these basically are based on Python. Cafe 2, of course, you don't need to write code. It's like you create a configuration file, say just describe the letter. It's like that and stuff like that. For all others, I basically are based on Python. So, and in particular, the two most important one, I'm not sure I should say most important one, but most popular one is TensorFlow and PyTorch. I think like TensorFlow is more popular than PyTorch, but in academia, I think like more people use PyTorch. It's more friendly, it's friendlier for research. And of course, yeah, it's well promoted because Facebook is now it's maintained by Facebook AI, and Facebook AI is very active in research. Um, and TensorFlow, of course, is by Google. Um, and for you guys, if you don't know Fiano is basically by Joseph Banjo's group, but basically it's become obsolete because it used to be what I want to say like it used to be like TensorFlow is like it's just a copycat of Fiano. It copies all the features from Fiano's. Um, and of course, there's a huge backer like of like Google behind TensorFlow. So eventually, there's no incentive for the group like of Fiano to continue to like maintain Fiano. So they just like, drop that project. And Keras is actually interesting. It's a different project. It's it it used to be like separate from TensorFlow, but eventually the guys that he introduced like Keras, like he got hired by Google from another department. But then like after a year or two, then Google the people inside I mean, develop TensorFlow, maintain TensorFlow, just realized that the creator of Keras is actually inside Google. So therefore, they just recruit him into the team. So then Keras TensorFlow just merged. Um, and and that's like some other packages. I think Lasan, I'm not sure, is still around. Like it's like similar to Keras. It's trying to simplify the packages. So for example, you can think of like TensorFlow is like more like what should I say? Uh, Assembly would be an exaggeration, but maybe mm, yeah, that is not a good analogy. I guess okay, and exaggeration is okay. Maybe assembly is TensorFlow is more low level, then Keras is on top of that is C, something like that. And also Lasan is similar manner. So it's like you in the past actually for Keras you can use different backend. For example, you can choose backend like with Fiano or like TensorFlow. Of course, most nowadays mostly just TensorFlow. And Lasan also like you can. I'm not sure you can choose different backend, but anyways, I can't also good. I mentioned MatConfLat already. MXLat is another kind of I would say pop. I'm not sure how popular is that. I would. My feeling is like much less popular than PyTorch and TensorFlow, but is backed by, I believe, Amazon, and it's claimed to be fast. I'm not sure about that. If, for you guys, is if you're interested, you may want to look into that out as well. Um, and yeah, okay. Okay. Another question. In terms of platforms, what do you use uh, most often? What's the platform that you use most? Linux, Windows, Mac? Yeah, that's a good answer with GPUs. Any of you guys are using GPUs as well? GPUs is important in this area because when you train a model with GPUs, you get much more uh, gain in terms of. Don't worry about that. You don't have GPUs. I will talk about after this. Just show you using Colab. I'm not sure how. Yeah, probably some of you already know Colab. This from Google, and you can use Colab. I think the GPU is kind of for free for a short period of time. So if you just work on a homework assignment, uh, you probably can just use Colab. Yeah. So and yeah. So but in any sense, it's good to install. If you haven't yet, try to install maybe PyTorch or TensorFlow on your computer, or you may install other packages, maybe and mix that. And no matter which packages you want to install, just go to just search for the package. Right, they have very detailed, well documented installation instruction for your platform. But it is not. It's a homework still. I'm not going to basically grade you guys, but try to install any of these packages and play with them. Maybe play with either if you okay if you haven't played with anything before, consider either PyTorch or TensorFlow. I guess if I guess I would put it this way: if you are more, for example, you're just thinking, okay, I will get a master and get a job right away, then maybe TensorFlow is better because I guess it's more industry adoption. But if you are more kind of geared towards research and you want to stay for PhD either here or apply for PhD somewhere else, PyTorch may be a better option. So for one thing, I think PyTorch is better for debugging. So yeah, so you can consider these two. I guess if you don't have anything in mind, think of these two and then try to install on your machine and then play with that. Uh, and this is the tentative coverage is very rough. It's going to change. I guess I put this down a couple years ago. Uh, this is very much some of these topics I follow what people teach on, for example, the famous Stanford course 231 and um, at that time. Now, I don't think the course is still open anymore. Of course, you can uh, look back for previous offering, but I think the latest version or latest offering is not online available, not available online anymore. But um, yeah, so this is an introductory course, right? So we'll talk about, of course, some classic neural network, maybe multi-layer neural networks. We'll spend some time on backpropagation algorithms, uh, some regularization. Actually, we will even talk about some machine learning first, because after all, neural networks is a kind of machine learning, and I'm also yeah, we'll talk about supervised learning. Oh, okay, and um, I mean, if you think of learning, machine learning, all this, ultimately it's really doing optimization problem. Like you have training set, you design some cost function, you are just what you did or what the your um, what you program to ask your like open source package did is just doing optimization, like trying to minimize the objective function according to your training set. So we mentioned some optimization methods like um, and of course we talk about CNN is like so widely used like everywhere. It's convolutional neural networks. Uh, and we look at some application of CNN, maybe also way visualization of some of these networks here for the CNN there. And we talk about recurrent neural networks. Uh, and oh, okay, that's stuff that presented by you. So it can be neural network packages and so on. Um, or like if you have some interesting applications, or like if you go through the textbook, you have some chapters want to in particular attract you, that you're interested to dig deeper by yourself, like uh, and you would like to share with others. To be honest, like always, teaching is the best way of learning. So if you want to learn the new areas fast, the best way is like try to read something and then share with others. Like then you will learn the fast actually. Yeah. So so try to dig into the textbook, like just flip it through and see if you have any topics that you find especially interesting. Then maybe you can consider that as like a presentation topic. We will look into some applications like computer vision, maybe NLP. I'm not sure like how much we're going to NLP, and we'll talk about retrieval machine maybe, and autoencoder. Definitely, we will talk about autoencoder. Oh, actually, I even didn't put GANs there. Uh, yeah, of course, we'll talk about GANs. Now is we probably will talk about self-supervised learning. Also, I didn't put it here. Uh, and we talk about the reinforcement learning, capsule lecturers. I work on capsule lecturers, but I'm not sure we'll talk about that. But we will talk about attention networks. It's very useful. Like, it's actually um, attention networks in some sense is over uh, performance-wise. I kind of in some application it's like it's getting ahead of CNN already. So some in particular recurrent neural networks. For example, in NLP like attention network is like replacing recurrent neural networks in many NLP applications. And of course, just like a couple years ago, like recurrent networks is what's that word? I cannot say it anyway. Revolutionize, yeah, revolutionizing the whole NLP area. But now already have some new candidates at the attention networks coming up. And I may talk about graph laterals. Like that's something I'm interested in, like, but I'm not sure. Like, I need to dig into myself. Like I need to study myself. I don't know enough yet at the moment. But yeah, I may know enough to talk about that like later in this course. And that's basically the tentative stuff we want to cover. Uh, Prerequisite, as I mentioned, Python is very important, necessary to know Python. So I mean, it's easy as well. Like don't get scared about that. Like especially if you already know like MATLAB, C++, and Python is much easier than C++. And when I say Python, I usually mean Python plus NumPy because PyTorch is very similar to NumPy. NumPy is the numerical Python. So NumPy is similar to MATLAB. You can think of like you work on a matrix at a time. You can like have a matrix multiply another matrix. You can like just introduce a matrix, then do an inversion of them, an inverse or yeah, inverse. Do the inverse of the matrix, and so on and so forth. And maybe compute the SVD, like and so on and so forth. Yeah. And there's a tutorial like Python NumPy by Justin Johnson. So you may take a look if you don't know Python yet. Just get familiar with that. And I expect you guys to know some college calculus and linear algebra. Uh, I I may review some of this material, like not a lot, just when I get into those materials that um, need to know some linear algebra and calculus, maybe I will mention them. But yeah, you probably yeah, it's a graduate class, so I assume you know pretty well these materials. Um, and I won't go into like really proof, but like maybe some derivation here and there. Um, always like math is useful, like very important because packages, API, they keep changing. Like it just think of TensorFlow. You have like a piece of code like that support like TensorFlow like 0.7, like definitely won't work like for the current version basically. So they have very short life, like all this API you learn this. Of course, if you're working this as your bread and butter, like or like in the sense that if you need that for, I mean, daily for your living, then of course you will keep updating yourself. But if you learn this now, uh, these packages, and like 5 years later on, you come back to work on this area, I can assure you the math you learn like from this class is much more useful than whatever packages you're working on, because who knows, like, I don't know, like 5 years later, so maybe there's no TensorFlow. It's very hard to say. I don't know how many of you know Perl. How many of you know Perl, by the way? How many know what is Perl, by the way? Okay. By the way, when you say you don't know Perl, do you know like even what is Perl? Okay, that's great. Yeah, Perl is a programming language. It used to be very popular, and 20 years ago, 2 decades ago, I was learning Perl to do some, I mean, for my everyday scripting things. Um, and yeah, you can imagine that like someone nowadays in your generation, like some of you guys don't even heard of what is Perl. So what I mean is like you don't know, like maybe a decade later on, like Pythons will be replaced by some other languages. So what I mean is like, but the math I learned like 3 decades ago is still very useful. Like and the linear algebra, like we are still using like linear algebra. People invented like, I mean, 200 years ago. So the math is like basically stay there for your entire life. Yeah. So don't get scared by math, and um, be more friendly with math. I mean, uh, don't get whenever see math, you just feel, oh, I don't want to look at that. Actually, in the long run, they are the most useful stuff. I hope I have taken more math class when I was a graduate student, but I didn't. And it would be very useful. I hope I took, for example, a differential geometry class, let's say. Um, that would be very helpful. Now, if I need to learn it myself, it's very hard, actually. And so that's basically the prerequisite. Okay, let's get into some introduction. Like just one slide in deep learning. At least my interpretation is like, okay, fancy word saying that like deep, like when we say deep, it's basically just multiple layer. You can think of layers of laterals, but more generically, more generally, you can think of layers of like uh, representation, basically. So in a level sense, if you think of artificial neural laterals, it's just more than one layer with a deep laterals. Of course, like 2 layers is not so deep, but you can get more and more layers. You can think it's like deeper and deeper. So it's so popular because it's just the most powerful machine learning technique at the moment. So any basically, if you look at any machine learning computations across the board, any over the what's that called, like on the top is always based on neural networks. Um, some taxonomy, I would say, like some my interpretation of AI. So different top, top terminology and different discipline. So of course, you heard of like AI and machine learning. That's actually something I'm not sure you heard of representation learning that came up like several years ago. Like people when talk about deep learning, where they're thinking of like they have this uh, some layer of the ledgers is trying to learn the representations, basically, usually referring to the early layers. For example, if you have, maybe it's better for me to draw or something. Let's see. Yeah. So, for example, if you think of like uh, ledgers of course, I didn't really talk about like what the new ledger is supposed to be like. It's okay. I will talk about the next lecture or something. But you have a neural ledgers composed of many layers, then you can think of the initial layers. For example, you have some input, right? Inputs can be just an image, right? And then maybe you are doing recognition. Then output is just saying that is that a cat or cat, not a cat, right? So you can think of like the initial layers is doing some feature extraction or learning of a presentation of that input. So that's where the representation learning is coming from. And then like the later layer is doing classification. Now you have the earlier layer to learn the representation, you generate some features, like you can think of the output of some intermediate layer is some features, and then you have the later layers trying to classify from the feature into whether this is a cat or not a cat. And of course, deep learning, you can think of like kind of a special case of representation learning. So AI, there's also like for different people may mean different things. For science fiction, like maybe like many people think of AI as the strong AI, like think of like something very much not, I would say like still like open questions like in science, like for example, like can you build an AI to have consciousness, like common sense, like do reasoning? I guess reasoning is probably the first thing among these three able to be solved. Like um I don't know how fast, maybe like 5 6 years. It's hard to say. I guess like there's a chance that we may able to get reasoning out like in near future even, I would say. Um, and people didn't expect NLP progress so quickly, honestly. Um, and so, by the way, yeah, there's a very nice podcast is maintained by. Also, there's a YouTube channel like you can search for Les Freeman. He's a research scientist at MIT. But more interestingly, like he hold a podcast just interview like different people, AI people, like kind of famous AI people. Like for example, they interview like um, Joseph Bengio, like and he interviewed like Elon Musk, and also like not just AI people, like also like interview like industry people, like for example the inventor of Python and so on, the creator of Python, and of course like there's also weak AI is more realistic, like what we are looking at, like it's just like trying to help. When you say AI in this sense is really just trying to create a machine model that help us to solve some of the tasks that usually we think like can only be solved by human. For example, like in the past, like maybe a decade ago, like we find that it's very difficult to recognize an object from a picture, but now it's just become mundane task, I would say, like using neural networks. Um, Here and this some AI tasks. I guess I generated this list like several years ago, but I just keep it there. Like it's interesting. Like you see, like how these things. Like oh, by the way, like okay, that's another question. Like which of these problems here you think is most difficult? I guess this is an opinion question, really. Can Yeah, I guess like yeah. Uh, yeah, I shouldn't put this here. Actually, this it's apparently like okay, it's also a bit vague when I say understand the story. Like, there's a poem like people studying composition is like what's that called? I suddenly okay, it's slip out of my mind. So it's like trying to describe um the image that you see. For example, like yeah, image captioning. So basically, you have an image. For example, like you have an image that have a boy like holding a bat. Then you would just say you have a caption say a boy holding a bat. So if we consider that as understanding, then machine is doing quite well. But if we want real understanding, then machine is still doing really poorly. Actually, um, oops, uh, why uh, oops, that's bad. I suddenly remove you guys the chat. Why is that disappear? Okay, it should come back. So let me. I actually uh, how do I get? Okay. Yeah, I have another class. I guess some of the guys also in my other class as well. I just this earlier couple hours ago. Uh, I might pull up this picture. I guess this is interesting to consider here as well. So if we are trying to understand this, then in this is quite difficult. I don't think any machine can do it now. They would be able to, for example, like with no trouble, like recognizing all of the people here, basically recognize, okay, this is a person. Maybe can even do a perfect segmentation. So like there's a segmental, the whole person here, and maybe even can have a good great pose estimation, like estimate the pose is like that. But to understand like what's going on here, to understand that Obama is paying a joke to this guy here. I don't know who is this guy actually. I can only recognize Obama here. But for understand this, I don't think like any machine can do it, or like you can train a neural network to do this at this moment. I don't know how long people can create a model can do it. Um, Maybe in a level sense, maybe 10 years, I don't know. Like it's possible actually, like because it's really um the entire AI field is like kind of um, advancing really rapidly. Um, so let me move back to the other slides. Uh, yeah, okay. So this is a some of the my ranking at this moment. Maybe I'm wrong because for example, I used to think like playing strategy game will be harder than like understand story. But now, like if you're aware of like uh, DeepMind, uh, they they have basically DeepMind is like now owned by Google, and they have like Alpha Star. Basically, like they of course they have. I think I'm quite sure. Probably you guys heard of. Yeah, I'm not sure actually. I shouldn't assume that, but do you guys heard of AlphaGo? Like
Yeah,
AlphaGo,
yeah,
yeah. AlphaGo is like also like from DeepMind is like trying to play the game of Go as a old Asian game, like East Asian game. The rule is very simple, but it's very hard because like the board is much larger than a chessboard, and so therefore like the combination of move is like much larger. It's like people used to think like we to beat Go, we need at least like 2 more decades or something like that. But like just a year or two ago, like we just have like machine learning models like completely dominating human being on the game of Go. So actually, I'm not sure we should say like to beat Go. Like it's just like we're paying better than human in terms of Go. Uh, and the same situation, I guess, like now like that. I didn't keep um to the latest. I'm not sure like how uh Alpha Star is doing. But yeah, I will just guess like within 5 years they will be human on this. Um, uh, and Okay, let's move on anyway. So this is an interesting uh, figure. I don't know. Uh, Kind of like think of like what human are competence and non competence in, and and oh, well, I don't know, it's human competence or like yeah, I think it's human competence. This is in the sense compared with a machine. For example, like you can think of like chess, arithmetic, this kind of stuff. Like it's very hard for human. Uh, I don't know. Actually, higher is like I don't know how should I think in the sense it's like yeah, okay, I maybe should change the title here, but okay, I just copy the title from slide by Mass Techma. So I guess when it's higher, it means that the human is more competent on that. So maybe it makes sense. Um, and in terms of like chess and mathematics and so on, like, we're not that great with that, like compared with machine. But in terms of arts and so on, like it's it's hard to duplicate. Like programming, like I guess eventually maybe a machine can really replace people writing program. Even maybe if eventually we can do something descriptive, just saying that like um, try to recognize a cat, then maybe like you will have a machine do all the steps to gather data sets and then like pull in the data set and then to train the model and select the right model and so on. It's hard to say. Like it's really possible for that. Um, and but I guess like some of this insight, like, for example, like scientific insight, for example, like what Einstein did say, I don't think can be replicated by a machine. Like you need to have some kind of intuition, right? Because like ultimately, no matter how great we are doing in terms of machine learning and AI, at this moment, it's all statistics. So we just say have uh, the training data. Uh, we just want to make sure, like when we test our model, we will have the model is working as great as when we train the model with the training data. So therefore, like if your testing data when your testing environment is different for your training environment, it's very hard to generalize. So for example, if you think of relativity, you cannot generalize because like no one think of that before. Like you don't know how suddenly you came up with that. So that's the uh, I guess like that's the stuff that human is best at, right? So anyway, like let's move on. So I just want to mention this Winograd schema test in terms of like in case uh, I don't know. I probably like I'm not sure how many of you know that. Um, I at least I didn't. Yeah, to be honest, like 2 years ago I didn't know that. So this I know like for example like a Turing test. Like for example, if you want to test some system whether it's like true AI or not, the Turing test will be just P10, right? P10 like uh, have the machine P10 to be human and see if you can fool the your opponent. But the problem is like all this pretending is very easy to do nowadays. If you drag long enough, it's hard to really kind of realize whether someone is a machine or not. The Winograd test is trying to fix this. So they make a very simple test. Basically, Winograd is I think it's a Stanford professor or something. Where is that from? Sorry. Yeah, it's a Stanford professor. So he make up some of tests like this. For example, I have like two sentences here, like have a city councilman like refuse the demonstrators a permit because they feared violence. And now they changed only one word here. So here, like um, the city councilman refused the demonstrators a permit because they advocated like violence. So Now, for human, it's very easy to realize that what's they referring to here, right? They apparently they here is referring to the consumer here in the first sentence, but they in the second sentence is referring to the demonstrators. But on the other hand, for machine, this is a very difficult problem. Actually, I must stay at the top of like the current research, but I would say 2 years ago, like it's doing really poorly. Like for tests like this, uh, if you give a test like this to the NLP models, they basically just get 50% chance. That's basically not informative. Like uh, they the accuracy is like close to 50%, like a little bit higher than 50%. I assume that now it's getting much better now. I didn't stay on top on that. You may you may want to look into that if you want to present something. Like it's really it's something interesting. You can talk about that. If you're interested in that, you can look up the search for GPT-3 models. This is the model by OpenAI. But I think like Google has another model now. It's like even like have a larger size. Like but even for GPT-3, that's crazy because I just training the model itself costs several millions dollars. So of course this cannot be academic research. Like only big companies can do that, or like only like backed by some big companies is able to do that. Um, so anyway, uh, yeah, but you yeah, if you're interested, you can at least study that way. Look at like how good it is. Maybe like you can, for example, like for this particular problem, like Winograd schema problem, like how what's the latest model is working doing. Are they getting close? Are they getting like maybe 90%, like 80% accuracy now? Like, I guess it's an interesting story to share. Like, yeah, you you need to dig into literatures to figure that out. Right? And maybe you need to dig into like several different literatures and to see like what was the current kind of state of the art doing. And but be very careful. Like, uh, for this Winograd question, like if people are not careful designing the question, it will be useless. For example, like uh, they can create a question, for example, like the women like stopped taking pills because they were pregnant or carcinogenic. So now you can have like the question like this. The problem is like, okay, yeah, okay. Okay, I'm not clear like what I'm doing. Okay, let me repeat this sentence again. So what I want to say here, like I will do something similar as previously, have two sentences, but one sentence will have one word here is pregnant, and the other sentences I will have a word carcinogenic here. And then we would like to know what they here is referring to. So if we have the women stop taking pills because they are they were pregnant, that apparently they here will be referring to women, right? But if like I have like stopped taking a pill because they were carcinogenic, then we know they is referring to the pills. But for questions like this, um, it can be solved by statistics because you don't actually need reasoning, um, because uh, from statistics alone, we know that like only women like can get pregnant, and only pills can be carcinogenic. So if you decide a question like this, you don't need to know exact meaning here. You don't need to have reasoning here, but you can just based on statistics, then you can get very high accuracy if you for bad Winograd question like this. So therefore, like the construction, but of course, like this class is not about like creating like Winograd questions. Right? But yeah, this is just an interesting remark. Um, Machine learning overview. Wait. Oh yeah, yeah. Okay, okay. Here I guess many of you probably. Oh, actually, maybe another question. Say, um, yeah, just a quick question. Do you guys have any experience on machine learning? Either have taken a course on that or like have worked on projects that have used machine learning? Only machine learning I've done is deep learning. That's great. Uh, okay, I guess several of you have background with that. So I'll give a quick overview. What's meant by machine learning? It's a very simple concept, basically. So, uh, what I mean by machine learning, like, or maybe I start with the motivation here. So get back to the problem like I keep referring to, like let's say I have an image and I want to recognize whether the image is a cat image or dog image. So if you are a engineer, computer scientist, programmer, whatever, so and your boss give you this question, this problem, then the first thing is okay, maybe I should write a program to recognize a cat. That's my task, like uh, this week or something. So the problem is like, how do I get started? It doesn't seem so, okay. It doesn't seem like, I guess some of you guys, if you are a computer science background, maybe you have taken a algorithm class. So maybe you know everyone know like sorting, like for example, like quick sort or whatever. So if you need to sort a list, I know precisely what I'm supposed to do. Right? I can go to the book and I know okay what I should do first, what's the next step. Maybe I use bubble sort. Maybe sort is the easiest one. So I have a list. I just compare pairwise each one, like first pair, and see if like the first one is smaller than the second item. Then if the first one is like smaller than the second item, then it's okay. Otherwise, I'll just swap them and then compare each of the pair and then do it like many times. Then I'm done. Right? There's a very precise procedure for me to achieve the goal. But the problem here is that there's absolutely no way, no obvious way we can implement a function to recognize a cat. So like I need to write the Python code here, like I define a function, define predict, and input an image. So how should I write the code here? That it's very complicated, very difficult. Uh, or maybe I have another question, like trying to estimate the probabilities of a credit card fraud for a particular account or a particular individual. Um, based on his like credit history and other things, or maybe where he lives and other information, his age range, gender, and whatever. And there's no simple rule. We cannot just say, oh, because this guy is like uh, is 50 to 60, and he's his net worth is this, is less than $5,000, uh, and or like $50,000, and I will decide that he has a 50% or like 60% of credit card fraud or something like that. It doesn't make sense. Okay, by the way, I'm talking credit card fraud, right? It doesn't make sense. I shouldn't say the individual, but for this particular purchase, and then he buy uh, somewhere like online, like from a website. So therefore, I decide this is a credit card fraud. So, and also this is another problem. This is a moving target, right? So maybe you catch this kind of credit card fraud like by some kind of rules like at the beginning, but then next year like some scammer or whatever like design some other way to scam people. Then like that would be like um you need to add more rules basically, or like you need to adjust your rule. So it would be, even if you can design this rule, it would be very expensive to maintain that. So machine learning is just like you write program with data instead of writing the program yourself. So instead of writing the program here, you just like have collect the data and then build a model such that okay, I don't have slides for that, but anyway, so we'll be like I will have, yeah, so like this one here. So I will just say determine a model. This is my model here. Now what I'm going to do is say I will prepare data. So I have maybe like some cat image here, and there's some not cat image here, right? So I have many cat images, and I have like also many not cat images. Now, I know beforehand like which are the cat images and which are not the cat images. Then I can all plug into these models. And by the way, the models here, these parameters, I contain some parameters that can be parameterized, that can be changed. So I can tune this parameter. So basically, you can think of this as just a function that will accept some input. This input is just image input. And this parameter theta, I can change that. So with some image like coming in, will determine whether it will give me maybe one will be cat, right? If zero is not a cat. So then what we are going to do is like we will just like trying to tune this parameter theta such that like I will correctly, uh, accurately uh, classify the training data. So if I have the images is coming from the cat data set, so I should all recognize to be one. If I'm kind of pulling data from the long cat data set, so I should all get zero here. So that's the high level understanding of what machine learning is doing. It's simply you determine a model and then you try to modify the parameter or like learn this parameter here. And in the way to learn it, then like you want basically uh, I have data. For example, I have cat data, and maybe I put a superscript cat here. Like these are all the cat data here. Maybe like have cat data. Like I have cat data one image cat image one, cat image I, up to cat image. Like I have like n of them. Let's say, right. And maybe I have long cat images. Oh, actually, I'm almost running out of time. So, but maybe I will almost stop here. So I have long cat images, and maybe uh, long cat is one. Oh, wait a second. No. I still have time, right? So start with 4:30. Wait, I get confused. 4:30. So it should be, uh, no, actually,
It's
I'm
it's
almost out of time. Yeah, yeah.
5:45 is
Yeah.
the
It's
time.
right. It's right. Yeah. So I'm
Okay.
almost run out of time. So let's say I have like long cat images like that. So right. So then the goal here, like this is the training data. This is the training data, right? So what I want is I want to make sure this I get correct classification of this cat image into cat, right? And this long cat into long cat, right? So therefore I should find the function such that like these cat images should be close to one, right? So this should give me one. So I can sum over all this, say I equal to 1 to n, right? Maybe I can just make sure this is 1, right? And then for the long cat is should be 0, right? So then this can be a cost function, right, for that, right? This can be a cost. If I do it perfectly, then if my theta is perfect, then I will just get this cost is 0. So, or like you can cost function or loss function, whatever, or like cost or loss. Many people call it loss function. Maybe loss function is better. So then I can define loss is based on theta, right? So now I should tune theta such that my loss is minimized. So basically, I'm just doing an object optimization function problem that I'm trying to minimize loss uh, with respect to theta. And that's it. That's a basic machine learning. Um, I okay. Let me continue next time then. So, and please try to install like packages um, on your own computer and if you have a chance, like play with that. And if you're not familiar with Python, and try to get familiar with that. So okay, I'll see you guys like on Thursday.
Thank you, Professor.
Yeah, sure.
Dr. Cheng,
Yes.
did you say you wanted us to introduce ourselves on the Discord, or?
Oh yeah. Maybe just write a couple words. It's okay. Like just a few words.
Yeah,
like,
yeah.
saying,
Okay.
like, what you're doing. That I guess that's okay. In particular, maybe like you guys would like to collaborate on project. I don't know. Then it probably is great to know each other. Then maybe there's a chance to collaborate for project. Or maybe you can talk about like whether some of you guys probably you want to coordinate like with your presentations as well. So you don't want to have preferably too much overlap on the topics. So yeah.
Right. Sounds good. Thank you.
Yeah, sure. Okay. See you guys on Thursday.